Hello, welcome back. Well, you remember I made an allusion to an absent-minded professor. In the previous lesson, I announced, I'm going to do this in the next lesson. After I turned off the video, I forgot completely, rubbed off everything. And while I am recording, unless it has been edited, I can't see what exactly was the question. So I'm so sorry about it. So I would suggest that we start with a new question. So now, in other words, application of aCosx plus bSinx, etc. to maximum and minimum. I'm sorry about it. I should have realized, but I forgot completely. So I'm sorry. That's all I can say. So let me take an example. Express 5 cos x plus 12 sin x in the form r cos x minus alpha, where r is greater than 0, 0 is alpha less than 90. I'm not going to say those things. Hence, state the maximum value of y equal to 5 cos x plus 12 sin x. Find that's part A, part B. Find the smallest positive value of x for which y is maximum. Part C, find the minimum value of y squared equal to 5 cos x plus 12 sin x the whole squared, stating the smallest positive value of x for which y squared is minimum. Okay, I made up another question. I'm sorry about the previous one. Anyway, I can't help it. Okay, so what I'll do is, remember, I've rubbed off all those because format, that's a plus. When you expand cos of a minus, this is going to be a plus. So the format is okay. So you straight away start with, remember, that's your A, that's your B. So A is 5, B is 12, R is root of 5 squared plus 12 squared, which is 13. Then alpha equal to 12 over 5. So alpha is shift tan 12 over 5. Shift tan 12 divided by 5. 67.4. That rings a bell. Doesn't matter. So therefore, I can straight away write this as 13 cos x minus 67.4. Okay. So that's what I will use now. I've shown you this, I've given you in the last lesson. So you have it. So therefore, I can say for part A, y equal to 13 cos x minus 67.4. It says state the maximum value of y. Look, that's a cost function. any cos function, biggest value is 1, smallest value is minus 1. So 1, when this becomes 1, y becomes 13. When this becomes minus 1, y is minus 13. So if you're asked, if the question said maximum and minimum, you'd say plus minus 13. But since it says only maximum, therefore maximum y equals plus 13 or 13. It says, remember, state. That means we don't want to know. You get 1 mark the moment you write 13. Okay? But that doesn't stop there. It says, find the smallest positive value of x. To do that, remember the first couple of lessons when I drew the graph of sin x and you suppose the graph of cos x and tan x? Good. Let me draw the graph of cos x. Idiot. That is the graph of cos x. That's 1, that's minus 1, that's 90, that is 0, that is 360, that is 270, and that is 360. And that is 180. Yeah, that is y equal to cos x. Okay. Now, when does cos x become 1? Cos x is 1 when cos theta, let me use theta instead of x. Cos theta is 1 when theta is 0. Cos theta is 1 when theta is 360. So therefore, but your theta here is x minus, therefore, part B, x minus 67.4 equal to 0 or 360. Why do we consider both? Because if this were to be plus, I would get a negative angle. Then I need to go for the next one. So x equal to 67.4. That would be the angle where y becomes maximum. Good? That was easy. The next one is a bit difficult. We are now interested to find out y squared. That means I need to draw the graph of cos squared. We have never drawn it, but it's common sense as I will show you. Zeros don't change, correct? 90 and 270 does not change. Remember, every value of cos x is less than 1. So when you square it, it's still going to be less than 1. But the biggest value of cos x is 1. So the biggest value of cos squared x is also 1. And smallest and cos squared x is 0 at 90. What happens between 90 and 270? Between 90 and 270, cos x is negative. But when you square a negative number, it is not a modulus graph. When you square a negative number, you're going to get a positive number. So the least value is minus 1 becomes 1. So that again becomes a maximum. This is the graph of y equal to cos square x. So what is the minimum value of cos squared x? 0, not minus 1. So for part C, minimum is 0. Where does it occur? 90 or 270? So x minus 67.4 equals 90 or 270. Why did we write 270? If this was plus, I might have to, oh no, I don't need to. So x equal to 90 plus 6157.4 is the angle, smallest positive angle, where it is minimum. So I had to take this example to show you how you apply the question to minimum and maximum. I'll take another example, just one more, something similar to that. This time I want to use sine instead of cos. Okay. This time I want to use sine instead of cos. Example. I don't know what the example number. So express, what should I say now? I have used cos, I need sine, and we've used 12, and shall we use 8, 15 and 17, or 24, 5 and 25? Is it? Yeah, 476. No, 625. Anyway, we'll look at, I think 24. What's 24? Yeah. 625 minus 573. What is the 24, 7 and 25? So let's use that. Express 24 sin x plus 7 cos x in the form capital R sin x plus alpha, where R is greater than 0 and 0 less than alpha less than 90. Part A. Hence, find the maximum and minimum values of y equal to 24 sin x plus 7 cos x, stating the smallest positive angle x where these occur. Okay. Part B, find the minimum value, minimum and state the minimum and maximum values of part 1, y equal to 1 over 24 sin x plus 7 cos x minus 25, so minus 10. Part B, 1 over 24 sin x plus 7 cos x, the squared minus, plus 2. Okay, I've just taken up some examples, don't worry. Alright, so as usual, format, that is plus, sine and sine, so format agrees. So that's your A, that's your B, R equal to root of 24 squared plus 7 squared, which is 25. Tan alpha equal to B over A, always B over A, 7 over 24. So shift tan bracket 7 divided by 24, close bracket, 16.3 degrees. So therefore I can straight away, you get 1 mark for writing that, or 2 mark. So I will straight away go to part A. So part A is y equal to 25 sin x plus 16.3 degrees. Okay. Find the maximum and minimum values of that function. Alright. Remember, y is a sine function. So, should I put this 1 over? No, let me not use 1 over here. Okay? Alright. That's it. That's okay. Y equal to. So, I want to draw the graph of sin x. That is the graph of sin x. 0, 180, 360, 270, 90, 1, minus 1. So maximum value of any sine function is 1. When this sign is 1, y will become 25. When that sign is minus 1, y will become minus 25. Please don't say plus minus 25, split them. So therefore, y max equal to plus 25 when is sine maximum. Sine is maximum at 90, or x equal to 90 minus 16 is 64, 63.7. And then y minimum is minus 25 when the angle, when is sine minus 270, or x equal to 270 minus 260, 254, 253.7. How? 270, 260, 90 minus 16 is 74. So 73.7. Yeah, that's okay. So draw a sine graph, pick where it's going to be maximum or minimum, equate the angle to those angles, and put the, always it will be, if it's sine or cos, it will always be plus or minus 25, maximum or minimum. Okay. Let us look at the next bit. In part B, I want maximum and minimum values of y equal to 1 over, what did I have? 25 sine x plus alpha. What was alpha? Can't remember, doesn't matter. 16 point, I have the alpha here, 16.3 minus 10. When is a fraction maximum? A fraction is maximum when the denominator is minimum, and a fraction is minimum when the denominator is maximum. So maximum y will be 1 over, very interesting, minus 25 minus 10. So it is minus 1 over 35. Some logic is wrong somewhere, we'll see. And then what is minimum y? When the denominator is maximum. 25 minus 10. Okay, it doesn't matter. Then once you get the value, then I will decide. 25 minus 10, which will be 1 over 15. 1 over 15 will be maximum. 1 over 25 will be minus 1 over 35 will be minimum. Why? Because that's a negative value below the x-axis. There is no asymptote either, because that can never be, oh yeah, it can be 0. So there is an asymptote. So it's perfectly alright. I think I took a stupid question. I'll put it as plus 10. I think that's best. When the denominator is minimum. Minus 1 over 35, it's no, still doesn't matter. So it doesn't matter, it doesn't matter. There is an asymptote, I forgot. But I wanted to bring out a concept, so that's fine. That's why max, and that's why min. Oh, sorry, it's a cosec function, isn't it? So it works. Boom! I should have thought of it. It is asymptotic because that can be 0. If I put it as, let's say, 30, then it wouldn't have worked. Because 30 is going to be 30 over 25 is more than 1, so you won't have any roots. Okay, that was just to show you how to do it. I should have been a bit more careful. Remember, I make up this question, so I change the number to 10. I should have changed the number to 30. Let's change it to 30, so there is no problem. So minus 25 plus 30 is 1/5. Then plus 25 plus 30. Now minimum and maximum makes sense, doesn't it? So I'm avoiding what you call an asymptote. Okay. What about this one? Y equal to 24 sin x plus 7 cos x the whole square would be the same as y is 625 sine squared x plus 16.3. If I were to draw the sine squared graph, as I told you, it will be like this. Maximum is 1, minimum is 0. So y max equals 625, y minimum equals 0. This don't come, I should have thought of that. This should have been 25 plus 30. Okay, 55. How many errors? You see, just because, these things happen, I should change it to be consistent. Okay. So 25 minus 30, that minus 25 plus 30 is okay, 25 plus 30 is 55. That's how I just took some simple examples to show you. Sometimes they ask you a fraction. Remember the rule, the fraction is minimum when the denominator is maximum. A fraction is maximum when the denominator is minimum. Don't worry, you will not get asymptotic behavior. It will just be in one quadrant. In other words, you will have the values which will not make the denominator 0. Okay? Next. Whenever it's a square, the maximum value is 1 for sine or cos. Minimum value is not minus. For a square, it is 0. So the safest way will be for you to use the graphs of sine and cos and sine squared and cos squared. That finishes discussion of aCosx plus bSinx. We have come to one stage in trigonometry. I'm not going to do sine and cosine rule. I'm not going to do area of a triangle. Well, the one which is we're going over all these things again, taking different examples. We're going to start radians the next time. Okay? That will take me another 2-3 lessons, and we come to the end of trigonometry as we know it. Okay? At A level. Okay then. See you. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.